Hello and a warm welcome back to my YouTube channel. This is one of my favourite little reactions. It's not particularly scintillating, but I find it very exciting for a couple of reasons. One is it turns up on the IB papers a lot. First of all, we have a solution of copper 2+, it's good old copper sulphate. Remember, copper ground state is 4s1 3d10, so copper 2+ is 3d9. We have unpaired d electrons in the copper, which is giving a phenomenon of colour. It's absorbing the red end of the spectrum and transmitting the blue end to your eye, so it does appear blue to a human being. I'm sure people will tell you what it looks like to a dog. I'm not convinced anyone's got their brain inside behind some dog's eyes. Anyway, I digress. We have a nice sample of magnesium ribbon. If I throw the magnesium ribbon in, taking care of all my health and safety precautions, of course, using my hand. There is some magnesium ribbon. I will dunk, put, place, whichever adjective you choose, the magnesium into the copper sulphate. It's actually quite a dilute solution. This one is 0.08 mol per decimeter cubed. You can see quite nicely on this camera that we're getting bubbles forming. The bubbles formed are a result of magnesium reacting with the water, making the magnesium hydroxide and hydrogen. The magnesium is quite light, it's low density, so it's floating, almost floating, certainly at the top of the beaker. The magnesium is going to end up as the ion, so Mg is going to go to Mg2+ plus 2 electrons. Do those 2 electrons just hang about and do nothing? No, they don't. They're picked up by the copper ions. More health and safety at work. The copper ions pick up those 2 electrons, and we should get some copper precipitated as I talk through this video. So Mg goes to Mg2+. That means Mg to Mg2+ plus 2 electrons. That means it's oxidized, so magnesium is the reducing agent because it's forcing the copper 2+ to pick up 2 electrons to become copper. Because the copper reduces, it is the oxidizing agent. And it's always nice to see a couple of things. One is as the bubbles of hydrogen coalesce around the outside of the magnesium, it causes it to float a bit more and rattle up and down and move around as if by magic, but it's better than magic, it's science, right? The other thing the IB like to ask about this is because the colour will actually fade. Why does the colour fade? Because the copper 2+ becomes copper metal. You can see that being precipitated, liberated at the bottom of the beaker. These brown bits are solid copper, and we can also see the magnesium is disappearing. The blue goes because there's no copper 2+ left in solution, or there won't be as this video progresses, and hopefully all the magnesium will be gone within the space of about the next 5 minutes. I'm not going to wait that long, that's all I wanted to cover. Hope you enjoyed this little experiment. Thanks very much for watching. Like, comment, subscribe at the bottom. Thank you.